Hi, I'm going to be walking through question 9 of round 1 of the Maths Teams Olympiad competition. This question was quite painful to do. I spent ages trying to square a load of times, and it was clear that wasn't going to work. I wasn't able to solve this problem when I originally had a look at it, but I think if I had a much longer time and in a team, it would be solvable, so that's why we stuck it on the competition. So you can do some factorization. It may not be clear, but if you factorize a root x out, you have to be careful what you choose to factorize. So we're going to choose this pair here, and in a separate color, we're going to choose this pair here. So I'll start off with the red one. We can factor out root x times root x. So when you multiply these two together, you obviously get the x, which is here. So you get x, and then you've got another root x in there, so root x plus 2. If you multiply this out, you see you get x times x plus 2. And you can do the same stuff for the orange terms here. Let me just finish that line off. You can factorize a root x plus 1 in both terms, and then you multiply that by root x plus root x plus 2. And you can see you get here you've got the root x times x plus 1, and the root x plus 1 times root x plus 2. So you've got a factorized form of your original equation, and as you can see, these two things here are the same. So we've got root x, lots of this in yellow, and then we've got root x plus 1, lots of this, oh, that's a bad colour, of that. So you can do some grouping of terms. You can say altogether you've got root x times root x plus 2, lots of root x plus root x plus 1, and that is equivalent to 2. Nice. So from then on, you may want to divide through by one of these terms and then rationalize. So we've got root x plus root x plus 1 is equivalent to 2 over root x plus root x plus 2. You can rationalize this by multiplying 2 times root x minus root x plus 2 all over root x plus root x plus 2 multiplied by root x minus root x plus 2. If you multiply it out, well, on the numerator you get 2 root x minus 2 root x plus 2, and on the denominator you get x minus x plus 2. So this is equivalent to, obviously the x's will cancel, and you'll get a minus 2, so this will be 2 root x minus, I'm going to factorize that out again just to make it a bit more simpler, root x minus root x plus 2, all divided by minus 2. This is just going to come down to be a minus 1 lots of this, which is going to be the same as root x plus 2 minus root x. And now we've got that equal to root x plus root x plus 1. Nice. If we add root x put to both sides, we've then got 2 root x is equivalent to root x plus 2 minus root x plus 1. At this point, it would be much more easier to square. Comparing when you're squaring up here, there'll be loads of different terms. Now we've got it in much simpler form. Squaring this will give 4x is equivalent to x plus 2 minus 2, x plus 1, x plus 2, and then this will be a plus x plus 1. Nice. Moving terms over, we then get on the left hand side, this is equal to 2x minus 3, and this is equivalent to minus 2 root x plus 1 root x plus 2. At this point you may want to square, and if you square the left hand side you get 4x squared minus 12x plus 9, and that is equal to minus 4 times x plus 1 times x plus 2. So that's going to be 4 lots of x squared, and then that's going to be 3 times 4, that's going to be 12x, and then 4 times 2 plus 8x. This is equal to this. And we've got a linear equation here. So we can multiply that. We get 1 is equivalent to 24x. Therefore, x is equal to 1 over 24. Those are your positive roots to the equation.